Hi there, my name's Andy Garbett and I'm here to present our paper towards understanding people's experiences of AI computer vision fitness instructor apps. I'm presenting this on behalf of my colleagues Ziedune Degutyte, James Hodge and Arlene Astell. During the pandemic, the physical distancing measures and forced closure of instructor-led fitness classes in shared spaces such as gyms has led to many people engaging with online classes and adopting fitness apps into their daily routine. Whilst it's well known that the benefits of exercise to well-being are positive, people can often struggle to know what type of activities can improve their fitness and overall health. As a result, we've seen a surge in users seeking out instruction, feedback, and guidance through health and fitness technology. Indeed, the Washington Post has reported a 47% rise in health and fitness app downloads worldwide in 2020 when compared to 2019. Existing work in computer vision for fitness is primarily focused on gaming platforms such as the Microsoft Kinect and require high upfront costs to purchase games consoles and the associated sensing peripherals. Although these original game-based systems are still popular, apps on mobile devices are widening access and participation for fitness in the home. Recent SDKs from Apple Core ML and Google ML Kit are supporting a new generation of on-device AI fitness technologies that have the potential to increase adoption given the prevalence of the mobile devices. Understanding and designing these advancements of AI is an emerging domain within HCI that is still being defined by industry and academia alike. The aim of our study was to investigate the emerging trend in AI fitness instructor apps and offer preliminary insights into people's experiences and expectations of using 6 fitness applications. For our study, we recruited 12 participants aged between 19 and 53 who varied in occupation, education, and fitness levels. Participants were assigned to use 3 out of 6 available apps, and each app was required to be trialed for 2 consecutive days with 1 rest day in between, over a period of 8 days. After that period, we invited participants to join us in a 1-hour interview over Zoom. We wanted to provide participants with the experience to compare and contrast these novel technologies, and this also ensured that participants had the experience and knowledge of the design language and functionality embedded within each app. We also wanted to minimize participation dropout rates due to the high physical activity required in the study. So the participants used all 6 apps for a total of around 1,200 minutes, with an average workout duration per session approximately 17 minutes in duration. We held semi-structured interviews with participants to discuss their experience of using these apps, and these interviews resulted in around 750 minutes of audio transcripts, which were thematically analysed by the research team. Through thematic analysis, we identified 5 main themes and 13 sub-themes. The 5 themes can be seen on the left-hand side, and they are limitations of computer vision, visual feedback, dialogue with the AI, adapting to the user, and working out with the instructor, and we'll go into those later in the presentation. So, starting with the limitations of computer vision, the majority of participants reported that the AI failed to recognize that they were in the correct position, and this would often result in incorrect real-time feedback or repeatedly asking participants to return to a visible position for the pose detection to work, and this included the AI counting incorrect repetitions or not identifying steps that have been completed, resulting in poses being held for incredibly long times, or incorrect verbal feedback on body poses. We were surprised actually how much space is required to use these apps, and indeed participants reported that in order to use these AI apps, they needed a lot of space. As P1 explains, it was like, please align yourself within the frame, just over and over again whilst I'm desperately trying to move bits of furniture, lie back down, look across to the phone to see if I'm in frame, and then I'm not in frame and having to repeat that process. And because that phone was so far away, users reported having difficulty seeing the phone's actual screen. When discussing a variety of visual feedback features, participants reported different preferences on what they wanted to see on screen, with some preferring to see the instructor only and others wanting to be able to continuously see themselves on screen, as the example on the right. Others preferred to see themselves only on screen when they got something wrong. However, as P12 explains, I feel like I'm doing something wrong if I saw my camera all the time. And importantly, the skeleton is useful for more slower and relaxed pose-based workouts as opposed to high-intensity workouts. Participants also found that real-time metrics such as repetition count, timers, intensity measures, and skeleton overlays were useful features to help track their progress, with the intensity measure being the most praised as it provided a strong sense that the system was able to detect their efforts. Participants also shared their experiences of receiving audible verbal feedback, such as beeps, dings, and pre-recorded feedback phrases. Participants found that corrective verbal feedback, such as lift your hips higher, and confirmatory feedback after participants had corrected their form, such as that's much better, was especially useful, even more so when they couldn't see the screen. However, at other times, repetitive corrective feedback was frustrating despite the participants' effort to correct their form. To this end, the AI lacked the ability to recognize the user's efforts and adapt to the situation by offering alternative feedback. Similarly, participants found that encouraging feedback was often delivered without regard to temporality, achievement, or context, as P5 explains. The AI would say, "You're killing it," but I haven't even started yet. How can I even be killing it? They've got these stock phrases that I just found laughable. And it was examples like this that demonstrate that these apps were unable to understand the temporality and context of the environment. Our study highlighted that existing apps do not accommodate for injuries and disabilities. And participants expected the AI to modify exercises in real time during an exercise and offer up exercise modifications if they were struggling. In addition, participants expected the AI to learn over time to offer them personalized workouts based on their performance and to fit into their workout schedule. And at the moment, Fitness Alley doesn't know if I'm going to pick her up once a week or every day. So how can there be any long-term planning there? And we found that there were 3 different class formats: the follow-along, the hybrid follow-along, and demo video. With the demo class format that used short video clips to demo exercises being more disjointed and less engaging than the other 2 formats. Indeed, participants preferred that a consistent instructor identity led the workout in a continuous follow-along format, and they felt more motivated by this perspective. So, based on our findings, we propose 5 design considerations. The first design consideration is to incorporate temporally relevant and socially relevant dialogue. The AI should be aware of what the user is doing and how to select appropriate audible or visual feedback for the user's current state, as well as understand when actions have occurred in the past, present, and will occur in the future. System designers should also aim to create an AI that is able to recognize poor conditions and inform the user prior to working out, rather than proceeding with poor lighting and space constraints to ensure that the AI communicates to the user how they should improve the scene. Thirdly, develop pose detection models that can be easily configured to take injuries and disabilities into consideration. Next, we suggest that designers design for a consistent instructor identity to help them build a relationship between the user and the AI instructor, and it's important to maintain the user's motivation and provide a visual reference to follow during workouts. However, the extent of this relationship is still unclear, and researchers need to explore how it mirrors the AI instructor's human counterpart as this technology permeates into everyday life. And the final design consideration is to provide long-term, human-like instruction that leverages the continued understanding of the user to create a more personalized workout experience over time. Designers should really draw upon the strengths of the superhuman AI to predict and understand trends over time and develop personalized workout programs. And with that, thank you for your time, and please check out our paper for more information.